Hello, this is the first video I'm going to try with this. One of the things I do with my DP computer science class is I create these things called OnePagers. And OnePagers are, in theory, one page double-sided that goes through a really core skill you need to be able to do. And so I have a bunch of them, and we'll see how this goes. So this one pager, I call it Bits, Bytes, and Truth Tables. So in the IB DP computer science exam, you need to be able to write truth tables, and you have to be able to write them quickly and accurately. And you have to be able to define some terms. So the first thing a one-pager has is definitions. So you need to be identify, a number of terms. And in this case, I want you to be able to understand and define what a bit is. And that's the smallest unit of data in a computer. A bit can be set to 0 or 1. And often we'll sometimes think of 0 as false and 1 as true. And it's the same principle at play. So that's a bit. Another term that's good to know, but it's not required for the IB, is nibble. That's 4 bits. A byte, which is an IB requirement, is 8 bits. A short is 16 bits. An integer is 32 bits. And it's good to note that an integer is a primitive variable type that is used across all languages. A long is 64 byte, and a truth table. And a truth table is a table that has one column for each input and a final column for an output. And like I say, being able to quickly write truth tables in a consistent manner is an essential skill. I remember back in university having to write truth tables and then realizing one day how you could do this very quickly. And that's what I'm going to show you right now. So if we think about a table, I'm going to talk about one possible input, 2 inputs, and 3 inputs. So our first case is a single input situation. So we just have one input, and that can be either off or on. And our possibility is 0, 1. And we're always going to write that as 0, 1. We're not going to write it 1, 0. And that's really important. We're always going to start with 0, and then the next one is 1. And we know that with one input, we have 2 to the power of 1 possible outcomes. Now with 2 inputs, we have 2 to the power of 2 possible outcomes. And what we do in this case is we write it like this: 0, 0, 0, 1, 1, 0, 1, 1. And you might start to notice a pattern here. And if you look at this column here on the right, we have B, which is 0, 1, 0, 1. And then A is 0, 0, 1, 1. And so what we do is we can really rapidly write out this truth table by following this pattern. And that our rightmost column is going to always be 0, 1, 0, 1. And we just keep doing that. And our next column is going to be 2 zeros followed by 2 1s. And if we have 2 inputs, we have 4 possible combinations. And that's how we get it quickly. Finally, we have 3 inputs, and this is the most inputs you would get on an IB computer science exam, but I really like you to understand the pattern so you can think beyond this. So here, we take our rightmost column, C, and we go 0, 1, 0, 1, 0, 1, 0. That should be a 1. Let me fix that right now. There we go, 0, 1. And then what we do now is we go to this next column, and we do 0, 0, 1, 1, 0, 0, 1, 1. And the question comes, well, what do we do in the next column? Well, now we do 4 zeros and 4 1s. And so you'll start to see a pattern in that the first column, you're swapping every time you're swapping, and the next column every 2, and the next column every 4. And if we continue this, if we had 4 inputs, this would be every 8 that we would swap. And this allows you a couple things. It allows you to very quickly write out these truth tables when you have to account for all inputs. And also it's a consistent way to do it. It turns out when you actually go through the conversion of this, this is actually, if you think of these as binary numbers, this is 0, 1, 2, 3, 4, 5, 6, 7. So it actually will write out your numbers sequentially, which is really nice as well. And so where do we see this? So here's a little note: the IB exams only require a max of 3 inputs. However, take note, this pattern continues as the number increases, as I mentioned above. So this is an old IB question. What we're going to do is essentially, it says construct a truth table for the following Boolean expression. So what we have to do is we have to evaluate this looking at all possibilities of A, B, and C. So if we come down here, let's zoom out a little bit. A little easier. Okay, so what we do is we start off by looking, we have 3 inputs here, so we write our 3 columns. And then we start off by going our rightmost column 0, 1, 0, 1, 0, 1, 0, 1. Our next column, 2 zeros, 2 ones, 0, 0, 1, 1, 0, 0, 1, 1. And our leftmost column here is 4 zeros, 4 ones. And what we're interested in is in the output. And so what I like to do is I like to show some process. This is nice because if you make a mistake, you can identify where you made this mistake. And as these get more complicated, being able to break them up into process and steps is really helpful. So in this case, what I've done is I've established A or B as D, and I've looked at not C or B as E. So in this processing step, I have D, which is A or B. And so what I do is I look at A or B. So 0 or 0 gives me 0. 0 or 0 gives me 0. 0 or 1 gives me 1. 0 or 1 gives me 1. 1 or 0 gives me 1. 1 or 0 gives me 1. 1 or 1 gives me 1. 1 or 1 gives me 1. And so now we know that every case down here. Now we're going to evaluate this not C or B. So what we do is look at C. So we're going to do the not first. That comes first in order of operations. So we're going to not C and then take the result and OR it with B. So if we see not C, so not 0 becomes 1. So 1 or 0, we get 1. Not C becomes 0, so 0 or 0 becomes 0. Not C, so that's 1 or 1 becomes 1. Not C, so that becomes 0 or 1 becomes 1. Not C, 1 or 1 or 0 becomes 1. Not C, 0 or 1 becomes 0. Oh, pardon me, let's do that again. Not C, 0 or 0 becomes 0. Pardon me. Not C, so 1 or 1 becomes 1. Not C, 0 or 1 becomes 1. And so now we have the second column. And we see that we AND D or E. So 0 and 1 is 0. 0 and 0 becomes 0. 1 and 1 becomes 1. 1 and 1 becomes 1. 1 and 1 becomes 1. 1 and 0 becomes 0. 1 and 1 becomes 1. 1 and 1 becomes 1. And that's it. So again, this one pager, really what I want students to do is to learn how to very quickly write out these truth tables and to see that pattern. And because this will come up over and over again. And this truth table kind of comes up in questions like this where we have to evaluate Boolean operators. With that, if you have any questions, please don't hesitate to reach out and have a wonderful day.